Okay, identify the limiting reagent, determine the mass of the excess reagent remaining when 3.97 grams of chlorine reacts with 5.10 grams of potassium to form potassium chloride. All right, this problem doesn't necessarily give me enough to easily do this, but technically everything I need is here. So the first thing I need to realize is to actually relate the chlorine to the potassium, I would need to have that balanced equation. So I'm going to start by making that. So potassium and chlorine to form potassium chloride. All right, balance this. I need two of these and two of these. And it does say, doesn't describe the potassium, but we're going to say solid. We'll say this is a gas and that's a solid. Now, those aren't really that critical for this. I just wanted to have it complete for this. All right, now I want to find out which is my limiting reagent. And I'm going to go do the strategy of just choosing one of these at random and seeing if it is enough to use up the other one. So I'm going to use the 5.397 grams of chlorine because it comes first in the question. All right, so I'm going to convert that into moles using the molecular weight of chlorine. So 35.45 times 2, got a molecular weight for a chlorine molecule of 70.90. Now, in my balanced equation, we see that 1 chlorine is needed to balance out with 2 potassiums. And now 1 mole of potassium, periodic table tells me that potassium weighs 39.10 grams. All right, so let's see what's the maximum amount of potassium I need to use up every bit of that chlorine. So 5.397 divided by 70.90 times 2 times 39.10, I see that I would need 5.95 grams of potassium. All right, I don't have that. I only have 5.109 grams of potassium, so therefore I know potassium is my limiting reagent. All right, but this question also wants to know what's the amount of excess reagent. So we actually have to do another calculation now because we did the wrong one on our 50-50 guess. It would have been much more beneficial to have done this one because whatever mass we get here for the mass of chlorine, we're just going to subtract from that 5.397. So I got to do another calculation. Fortunately, it looks very similar to that previous one. I'm going the opposite direction, I guess you could say, because I'm converting potassium into moles to moles, and then 1 mole of chlorine weighs 70.90. All right. Now this number better be under that 5.397, or else we've done the math wrong on one of these two. So 5.109 divided by 39.10 divided by 2 times 70.9. I get a mass of 4.63. All right, and now to get my answer on how much is left over, I'm just going to take 5.397 and subtract that 4.63 I just got. So 5.397 minus my answer. The amount remaining is 0.764 grams.